My name is Skylar McCaw, and I'm presenting my experiment on proving the frequency change seen in the Doppler effect using a DAC for data collection. The Doppler effect is the change in frequency that is observed when a source and an observer move past each other in space. This effect is most commonly experienced when a police car drives by and the frequency of the sirens seem to change from before to after it passes. This change is due to the change in frequency of the sound waves from before versus after from the point of view of an observer, which is shown in the graphic. The waves in front of the moving object reach the observer consecutively faster due to the movement of the object, while the waves propagating from the back do the reverse. This results in higher frequency in the front and a lower frequency in the back. The Doppler effect is used in fields such as astronomy to show the velocity of light-emitting objects, such as stars. To conduct an experiment to prove this phenomenon, I'm using a DAC to gather frequency data from a recording of a car driving past with its horn on. The first step in this experiment was verifying the DAC worked, alongside with the other components, using a tone generator. To do this, I set the DAC up using wires to connect the DAC and the audio jack at the GND and the AIN0 and the L or R ports. I then opened up the GTAE Simple DAC program and used the tone generator to verify that correct peaks occurred in the program correlating to the tone selected. I did this for 10 tones, then switched out the audio jack from microphone with the same wiring setup, except the AINO now connected to the out, and played the same 10 tones out loud. Once I felt confident that the DAC worked, I switched back to the audio jack and played the video of the car horn to watch how the power spectrum lines in the GTAE Simple DAC program changed as the car drove by. Here are the graphs of the power spectrum produced by the tone generator from the audio jack and the microphone. As you can see, the plots from the audio jack and the microphone are identical, which means the DAC as well as the audio jack and microphone worked and could be used for the second part of the experiment. As for the second portion, here's the video of the GTAE Simple DAC while the car horn video was being played. Looking at the power spectrum graph, the change in the frequency can be seen by looking at how the peak shift values as the car passes by. It can be seen that the initial peak values in the power spectrum are around 3,000, while after the car passed, it dropped down to be around 500. The higher initial peaks indicate high initial frequency, and the reduction in the frequency can be seen after the car passes, proves that the Doppler effect exists and behaves in the expected manner. In conclusion, based on the fact that the equipment produced identical and accurate results when tested, the data gathered in the experiment can be trusted, and the fact that it matches up with expected results further proves its validity. The data shows a higher initial peak frequency and lower peak frequency at the end. This proves that the sound change heard is caused by the frequency of the sound wave changing. How is information and data collected like this used? It is being integrated into cars to help prevent accidents. Devices inside cars record and measure the frequency of sound waves and use that to locate things like people, bikes, and other cars so it can avoid crashing into them. This technology is pretty new, and it'll be cool to see how it changes and improves over the next few years. Thank you.